Hi, I'm Emily, this is First Person Science, and today you're going to learn something. So today I'm playing Sonic and Sega All-Stars Racing. You know, that well-known smash hit. Everyone loves it, right? Right. I don't have any other Sonic games. I'm going to be talking about Sonic Hedgehog, not Sonic the Hedgehog. Sonic Hedgehog. So Sonic Hedgehog is a protein that's found in humans. It's abbreviated as SHH. The gene that codes for it is located on the 7th chromosome, and it's part of a family of two other hedgehog proteins. Those are desert hedgehog and Indian hedgehog. So it plays a huge role in the growth of limbs, digits, organs, the nervous system, and brain organization, which are, like everything about the body. So the hedgehog gene was first studied in the 1980s by a group of German scientists, Christian Nusslein-Volhart and Eric Weishaus. Those are names that I think I am pronouncing vaguely correctly. It was studied in fruit flies, invertebrates. The name of the hedgehog gene comes from this mutated embryo. They were studying this embryo that lacked the hedgehog gene, what then didn't have a name, and they noticed that it developed these weird small spikes, making it look like a hedgehog. So moving forward in time, a group of 3 scientists continued to study the hedgehog gene, the HH gene in vertebrates this time. So they discovered the 3 subcategories of the hedgehog gene: desert and Indian, which were named after real species of hedgehog, and then Sonic, which was named after a certain Sega video game character. So just like there are subcategories of the hedgehog gene itself, there are also subcategories of the Sonic Hedgehog gene. So there's SHHA and SHHB. So in zebrafish, SHHA and SHHB, they're duplicated. And those duplicates, they were formerly named, and I'm not kidding, Tiggy-Winkle Hedgehog and Echidna Hedgehog. When scientists realized that they made a silly mistake in naming them that, they just became known as IHHA and IHHB. But what does Sonic Hedgehog do? What's the point? Well, that's a good question, I'm glad you asked. It creates patterns and structures for limb development, as well as for the central nervous system and the brain and digits, like I mentioned at the beginning. So when an embryo develops, there are certain locations within it that have higher concentrations of certain proteins. So those different locations, they have what's known as a concentration gradient, which means it goes from a high concentration to a low concentration. So those concentration gradients, they distinguish the front from the back, the top from the bottom, and the sides from each other. They form the shape of the embryo, I guess. And those higher concentration areas ultimately determine the placement of limbs, digits, the development of organs, teeth, brain, etc. So cells have certain genes that control growth and development within the body. Those genes might only turn on or be activated when they reach a location with the correct concentration of a signaling protein like Sonic Hedgehog, because that's what Sonic Hedgehog is, it's a signaling protein. So when a gene detects a region with the correct amount, the correct concentration of a given protein, that's how it knows, this is where I need to build a leg, this is where I need to build fingers, this is where I need to build this part of the brain. That's how it knows where everything goes. It's responsible for the organization and the development of the body, as well as for the number of digits that grow. Like, it's because of Sonic Hedgehog that you have a certain number of fingers, a certain number of legs, because that's how many regions there are with the appropriate concentration required to start growing those limbs, those digits. It was also recently discovered that Sonic Hedgehog may be responsible for certain cancerous tumor growths, which has sparked some debate about changing the name of the gene and the protein, because it's not exactly great bedside manner if you're telling a patient you only have a few months to live because of a mutation in your Sonic Hedgehog gene. It's just a debate about the professionalism, I guess, of the name. Speaking of names, here's something interesting to close out this video. So signaling pathways in cells have things called inhibitors, which, as the name suggests, they inhibit that pathway. The inhibitor of the hedgehog pathway is called robotnikinin, named after the Eggman himself, Dr. Ivo Robotnik, Sonic's well-known nemesis. Hopefully you learned something new today, unless, like me, you pay close attention to just how nerdy scientists are. Bye!
Thanks for watching this video from BIGBITE. Don't forget to like, share and subscribe.